Now, we try to apply wave concepts to sound. We know that wave has several parameters: amplitude, wavelength, period, and related to it, frequency. So how are these parameters applied to sound as a wave? Wavelength of sound is simply the length from one compression to another compression. So if you identify which one is compression, so this length is the wavelength. We can also measure the length between the one refraction to another refraction as the wavelength, but we usually don't use this because it is more difficult to identify refraction as compared to compression. Now, we show you a simplistic model using wavefront of a sound wave. The compression is where the wavefront bunches together, and from one compression to another compression, so this would be the wavelength of sound. What about amplitude? The amplitude is the maximum displacement of a vibration. What do you think is related to which aspect of sound? I will now use a free program called Audacity to help you to understand what does a large and small amplitude of sound means. So I'm going to generate a tone using this program. So generate tone. Okay, you notice that we can change the amplitude of the sound. So you can change it to 0.2, or you can change it to 0.6. And you can see the sound wave is of a certain size and it sounds like this. Now I'm going to ask you to compare it to a sound when we use a smaller value such as 0.1. Notice the amplitude of the sound wave is smaller, and you can see it from the waveform. So what is the difference? You'll notice that the sound's volume is softer or smaller. So the amplitude of the sound is related to the volume of sound. The bigger the amplitude, the louder the sound. The softer the amplitude, the softer the sound. What about frequency or period? How would different periods of frequencies affect the sound? We'll use frequency as conceptually is easier to understand. Remember, the frequency of sound is the number of repetitions per second. Again, we'll use the program. So if we have a frequency of 128 Hz, it means that if the vibration source is vibrating 128 times in 1 second, and it will generate a sound like this. Okay, what if we double the frequency to 256? Okay, notice that the waveform changes as the waves are now repeating 256 times in 1 second. You'll notice that the pitch of the sound is now higher. And what if we double this frequency again to 512? Thus, we double the frequency to 512, we expect the pitch to be higher. Thus, frequency of the wave is related to the pitch of the sound. The higher the frequency, the higher the pitch. Otherwise, the lower the frequency, the lower the pitch. And for those that have musical background, you might have noticed that whenever you double the frequency, the pitch actually goes up by 1 octave. However, loudness of sound and pitch of the sound are not related. A loud sound doesn't mean that sound must be of a high pitch or low pitch. A high pitch doesn't mean that sound must be loud or soft. Just like amplitude of the wave and frequency of the wave are not related. So by comparing waveform of sound, we can generally know which sound is louder or softer, or has a higher or lower pitch. Some interesting sound facts. Do you know that we can only hear sounds of certain frequency? We can only hear about 20 to 20,000 Hz. But as we grow older, the upper hearing range is lowered to 16,000 Hz. So that's why there are some ringtones that only teenagers can hear, but adults can't. The sounds that's above our hearing range is known as ultrasound. Some animals have a wider hearing range than us, and dogs can react to dog whistle that emit sound that can go up to 50,000 Hz, but to us humans, the whistle is silent. So there could be sound that are present, but we could not hear or detect. Similarly, we can only see visible light, but there are lights that we cannot see, such as UV or infrared. And an interesting thought for you before we end the lesson, would there be something else that we currently could not detect despite our technology, but actually could be already present among us? So some acknowledgement. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.